Let's now look at inverse trigonometric ratios. And since we're still talking about trigonometric ratios, I'm going to start doing the same thing. I'm going to write so, ka, toa at the top of my page. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Now, inverse trigonometric ratios. What they allow us to do, if we have a trigonometric ratio, is to find the angle measure associated with that trig ratio. And on your calculator, and I put a little screenshot, maybe a little bit difficult to see here into this slide. This is a TI-84 plus CE. If I look just above the sine, cosine, and tangent button, just above those, I see sine -1, cosine -1, tan -1 in blue. And so if I hit these, if I want to find the inverse sine or the angle measure that I could calculate based upon a sine ratio, as an example, sine trig ratio, I could hit second sine, and it's going to bring up the inverse sine ratio. And if I knew the opposite over the hypotenuse, if I knew the side measures of an opposite side of theta and the hypotenuse, then I can determine the angle. First, though, I want to go into mode, and I want to make sure whether I'm in radian or degree mode, depending on what I'm trying to calculate. And I think for what we're going to be doing here, as a product of this video, we're going to be finding angle measures in degree. So that's kind of our keystrokes there on the calculator, and we'll bring up a calculator and actually do it once we put our equations together. Now here in this first triangle, we see, well, I want to find my hypotenuse. My hypotenuse is across from the right angle, so that's there. And we're asked to find the measure of A, so A is going to be our theta. Find the measure of A to the nearest tenth. So we know a couple of side measures here. And in relation to angle A, well, I know the opposite side, 6, and I know the adjacent side, 20. Okay, opposite over adjacent. Well, opposite over adjacent is a tangent function. So then I can find this angle measure by tan, inverse tan, tan to the -1, equals 6 over 20. And we're going to perform that calculation in a minute to come up with that angle measure. Now in our second triangle here, again, I want to locate my hypotenuse across from the right angle. There it is. I got an angle measure of 15. I'm asked to find angle A. That's my theta. And let's see, I know the adjacent side, which is 3, adjacent to angle A. And I know the hypotenuse, adjacent hypotenuse, adjacent hypotenuse. What trig measure should I use? Adjacent hypotenuse, cosine. And so this we're going to define then as the cosine, inverse cosine, when that equals 3 over 15. All right, we're going to do the inverse tan, 6 over 20, and we're going to do the cosine, inverse cosine of 3 over 15 to find our angle measures using the inverse trigonometric ratios. All right, here we are. We're back over on our calculator. We're going to perform this calculation. Now, the first one we had was the inverse tangent of 6 over 20. We're trying to find that measure of angle A. I first want to go and check my mode. And I do, in fact, see I'm in the degree mode. Fourth line down, I got the degree modes highlighted, so I'm okay there. So I'm going to back out of that, second quit, go back to my math screen, and I'm going to hit second tangent, which is going to bring up the inverse tangent function, and I'm just going to simply put in 6 over 20, or 6 divided by 20, close my parentheses, hit enter, and I'm supposed to round this to the nearest tenth, and shazam, that measure of angle A that we saw on the previous slide is 16.7. Now the second one we had was the cosine, inverse cosine 3 over 15. So again, I'm going to hit second. This time I'm going to hit cosine because I knew the adjacent and the hypotenuse. Coa, not coa, so toa. Second cosine, that brings up the inverse cosine, and this then is 3 over 15. Close my parentheses, hit enter, and wow, there we go. If I round that to the nearest tenth, that angle measure is 78.5. Using the inverse trigonometric ratio to help us find angle measures when we know side lengths. Next up, we're going to completely solve a triangle, and it will be fantastic.